Thank you for everyone joining in. For those that don't know me, I'm Daniel Leif. I'm a PhD candidate at the University of New England. What we are trying to do here is a continuation of something that we did a month ago, where we discussed with Colin and Sean about the excavation of V2 impact sites in the UK, and they've agreed to actually broadcast to us from a live dig at the moment in Kent. So I'll hand it over to Colin. At the same time, we know that the guys have to get their work done, so if they have to disappear, we'll continue the conversation from where we are at the moment, and write down any questions or whatever and email them to the guys, or do them in a follow-up after that. So I'll hand it over to you, Colin.
Okay, fine. Right, I hope you can see me. I'm just going to try and turn the camera around so that you can see what I'm looking at. So we are at Cliff Woods near Rochester in Kent, and this is the crater left by a V2 that landed on the 11th of November 1944, 22:04 in the afternoon. To date, we have been carrying out an analysis to try and understand what's actually happened here with the crater. It's an abnormally small crater. Normally, they're about 40 feet wide and about 10 feet deep. But this one was recorded at the time as being 27 feet long in one direction and 19 the other, but only 5 feet deep. And we have a theory about that, and it's those. This was a broadleafed woodland with lots of oak trees. If you followed any of our work before, you'll know that we came up with a theory about the missile detonating because of its colossal speed, 3.5 times the speed of sound on landing was the top speed. Its colossal speed would mean that it detonated as it was going in the ground, so it would bury itself. We believe in this case that it might have hit a tree and was detonating in that fraction of a second from the top of the tree coming down to the ground. That means that there was not as much resistance by the detonation between the ground and the missile. So just to contrast that with something else, we looked at a V2 missile strike at Linstead near Sittingbourne that was 60 feet wide and 18 feet deep at the time. We found the back of the warhead, the base plate of the warhead, which was very unusual to discover, which has made us believe that that particular one did not detonate. So this site at present, the line that I'm going to show you now, can you see that line there? That line goes all the way up behind our excavator, and it was coming in the direction that I'm standing. It's coming towards me. This is the major impact area here, and our magnetometer readings are very strong just in that area. So we've got the incoming trajectory, which actually means that, let's see if I can get my hand in this. It means that the Hague, where it's fired from, is that way. So can you picture the scene? 5 minutes before it landed here, it was being launched by Nazi Germans in The Hague, and it landed here. The crater. We're drying out a bit at the moment, so I'm going to use a bit of a trick here for you. If you look at the soil, we think we've got natural here coming across to crater Enfield. So that area there is roughly, can you see this? Is roughly where the crater is. When we measure across to the other side of the crater, obviously we're lower down to do this scrape. We get to here, which is not quite the right width. And that's only because we're lower. So that distance there is smaller because we're lower in the crater section. However, what's going on here is we've got a team of excellent digital surveyors on hand, JC White Geomatics with Andy Kay, where is he? There he is, who is recording the excavation in terms of laser measuring. So millions and millions of points, all recorded for future reference. And we're very happy because we're just excavating the platform that the digger is going to be sitting on in a minute, just to make sure there's nothing under here. And this is something that's just been digitally stored in situ. You're not going to be able to see this very clearly, I'm sure, but let's just find where the camera is there. That, with that classic profile and thickness of aluminium alloy, turbine. It's the pump that was driven by two chemicals to create lots of steam that would give the V2 rocket its oomph on the launch pad. Under its own fuels, it off. So at this point, you're going to receive a little lecture from my brother Sean that you'll remember from the meeting that we had recently. And he's going to tell us about how the missile was launched.
So the first very, very important thing was there was a team of surveyors that surveyed a suitable launch site. Had to be a hard standing. They then put a launch table down, and that table had a great big bearing in it, which enabled them to place the rocket on it. The bottom of the rocket had little lugs that engaged with the table. They then had to rotate it so that number one fin of the rocket was precisely aligned with the target. The next task was to make sure that the rocket was absolutely vertical. It was fueled, the measurements were checked again, and all of that took around about 2 hours to complete. Once they were ready for the launch, they had an igniter that they put up the back end of the rocket. It was a big long pole with a pyrotechnic on the end. The pyrotechnic, quite ironically, had 4 charges on it, and the person that designed it had actually designed it so it was in the shape of a swastika. Anyway, the pole with the pyrotechnic was put up into the combustion chamber, and then from the command vehicle, the taps to the alcohol and the oxygen tank were opened. The igniter was then detonated, and so you then had combustion in the combustion chamber. That only produced 11 tons of lift. As the device was nearly 14 tons, it wasn't going to lift off with that. That's where the turbo pump comes in. So potassium permanganate, hydrogen peroxide mixed together, huge volumes of steam which drove the turbine. Either side of the turbine were the 2 pumps, liquid oxygen and alcohol. With it being pumped down into the combustion chamber, that then produced 25 tons of thrust. That enabled the rocket to take off. Everything it had to do was pre-programmed. First thing it did was it lifted up into the air, and then after 4 seconds, so it was going vertically, the reference table for the main gyroscope was put to an angle. The rocket, because it's got little vanes here, so it's got graphite vanes and it's got air vanes. They all work together to actually keep the rocket on course. After about 60 seconds, there's a device up in the control room called an integrating accelerometer. When the desired velocity was reached, then the rocket went through what was called Brennschluss. So the supply of fuel was cut off. It then continued until it then went over the parabola and then into free fall. So it free fell towards the target, gathering speed as it went, until its terminal velocity was round about 1,100 meters per second. So if we were stood here all those years ago, we would have not an inkling whatsoever of what was about to happen. We wouldn't be able to see it coming, we wouldn't be able to hear it coming. There'd just be a massive explosion. So I hope that was of interest to you.
Thanks, Sean. I guess you're all dying to know what equipment we've got. Well, this is proved to be our most useful item because Post-excavation, we can tell an awful lot about what actually went on from the air. So a drone. The addition of the laser measuring is going to enable us to look at this on our computers at home afterwards and analyze where the finds were in relation to each other. As we look over to this sort of northwestern corner of the crater, the majority of the blast field debris, which was composed of the fuel tanks, aluminium shards, were deposited that into our best room in the building. I guess you all recognize this. And show you. Get this into the sunlight so you can see it. So that little piece there, let's just find the camera, that tiny piece was found on the top end of the crater. That's very interesting because of all the many V2s we've excavated, that piece looks to us as if it's come out of the control compartment. That would be a further indication that this is detonated above the ground, because normally you don't find those bits. They're in the ground or they're being completely incinerated. Let's try to get you into here. Right, blast field debris. Camera. Conserved turbo pump. Classic shape. Great big circular object, heavy duty aluminium alloy, and quite a bit of it. I'm struggling to find the camera, there we are. And all of this material here, just completely classic. Fuel tank. Now, one of our excavations at Horton Kirby in North Kent revealed something quite interesting. I'll try to remember to bring tomorrow. The fuel tanks had to be insulated because on re-entry from space, the wall of the V2 rocket was burning through and setting off the fuel and causing the thing to burn up in the sky. So it had to be insulated with glass fiber, but they held it in place with chicken wire. So that's a form of zinc coated wire that you use to keep your chickens in, you know, about an inch. In fact, the Germans, for some reason in their plans, describe that as 1 inch. I mean, we know they're metric, but on the plans it says 1 inch wire. Anyway, on the back of one of these items, from the blast, there was imprinted the chicken wire. I'll try to get that to you tomorrow. So lots of finds from the blast field, and the next bit of our process, once we've checked this area here, is to move forward to where we know that we've got very large readings indeed. So coming up, it's this section here. The top end of the crater lips up over here. These are the controls for the laser scanning device. Right. Okay, have we got any questions, Daniel?
Well, first of all, thanks for that, Colin, and to Sean as well. One question that I've got first up is, do you know of any other cases where a V2 has exploded in the canopy?
In the air, yes.
Or
We looked at one at Manston.
Have a look at it.
We looked at one at Manston in Kent, southeast Kent. The classic form where it bursts in the air is more than one crater. So at Manston, there were 5 craters and very, very small. So at one stage, we were considering the possibility that that was what had happened here, but there are no other craters. And the archive research that we've done, 2 major documents describe how the thing fully detonated. Yeah, they describe how it fully detonated. So we know that there's no breakup before it hit the ground.
Yeah. Quickly, does anyone else have any questions? Just raise your hand. Talia, go on unmute first.
Yeah. Hi, Colin.
Talia.
I would like to know if your project has the scope to do any kind of toxicology testing for the soil in the area.
Yeah, that's very interesting. Previous excavations we've done, when we got down to the proper fines layer, we've taken samples and we've taken them to a laboratory where they are microanalyzed using some sort of laser microscope. I don't know how the thing works, but it will do it many, many thousands of times. So you can look at the cell structure of what we've got. And we found, I was talking about the insulation earlier, we found a bit of ceramic fiber, which is basically glass fiber on a microscopic level. In terms of toxicology, we haven't been able to break apart easily what we see at that sort of magnification, because it looks like there's been a very, I mean, it's hardly surprising what I'm going to say, a very powerful burning time. So everything just looks like it's been completely frazzled under the microscope. The chap who was doing the work was a geologist and he knew what he was looking at, but he was completely amazed at this funny structure of the sample that I'd taken.
Interesting. Okay. Thank you.
Okay. Is there anybody else?
We've got some questions in the chat. Carl, I'm just going to quickly jump to Christine's question because it's just on topic. From Christine, do you know what geology this one has gone into, loam, or has it penetrated more deeply?
Oh, Christine, let me show you what it is. We know that this is the natural. Let's just turn this around. This part of Kent, we have a very awkward situation. Hello, I've got two people looking now. Is that Christine? Hi.
Yeah, it is. Hi. Clay.
Very heavy yellow clay. But when we're doing our preparatory work, we were trying to decide why this thing exists at all here. Not the missile. Why this lump exists. It's a big hill. It's the highest point of the region. And we're wondering if there's any stronger deposit underneath. I'm just trying to find this. Here we are. Let's see where I got the camera. That worried me, because there are lots and lots of bits of, well, it looks like seashore pebbles on the top surface. So we did wonder if there is something somewhere lower down. We're going to find out. In terms of the finds, we've drawn a diagram that a very wonderful physicist friend of mine has drawn a diagram that plots our finds over the years in relation to crater size. So at the moment, there's a bit of betting going on because he thinks that the finds are going to be 7.5 feet down. Sean thinks they're going to be 20 feet down. I've got a feeling they may be very close. So by tomorrow this time, I think we're going to be able to tell you the answer to that particular thing. It's got to do, yes?
Sorry, can I ask a favour? Can I have a look at what you were just showing, the rounded, yeah, the rounded pebble? It almost looks, I will say metamorphic, but I know it's probably blast induced.
Find some more. You see, the problem is, let me show you some more of the hole. Look.
Oh, look at that.
Okay. That's next to this. So
Yep.
we think that the middle part of the hole is infill. It's a crater.
Backfilled.
So, yes, but from this edge, the crater edge, it's no longer, sorry about that, it's no longer filled with the same type of clay.
Yeah.
This is a different,
Yeah.
it's basically from the same area, but you can tell this has been mixed a bit with loam from somewhere
Yeah.
else. But these things on the surface, who knows what it actually means? Was it just brought here and dumped in the crater?
I will actually say they almost look tectonic.
Ah, well, explain that to me.
In terms of meteoric, high temperature, impact, blast, you know, the debris that's brought up from meteorite, you get that very rounded, metamorphosed edges.
Well, those British viewers will be able to tell you about those. I'm looking for another pebble. We'll be able to tell you those pebbles that are basically composed of flint
Yes.
are very common around here.
Yep.
Beach called Dim Beach, where that's all is on the beach. So I don't know that this is caused by heat or any particular event. I think it's a prehistoric deposition, but I'm suggesting that somebody has brought that into the hole.
Right. How far are
Shall we
you
move
from
on?
the coast, can I ask?
Sorry?
How far are you from the coast?
We are a considerable way. When you look at the map, if you look over Rochester, there's a comes up through Rochester. So can I just ask Sean? Sean, how far are we from the coast, would you say? 15,
The estuary.
10, 15 miles?
Right. Yep.
How far?
Less than a mile to the estuary.
Oh, apparently we're less than a mile to the estuary.
Okay. Yep. Cool. No, thank you.
Are there any other questions?
Yes, so from Carla, and then we've got a similar kind of following up from that from Adam. We've got, she just says, you know, not her area of expertise, but how many known sites are there in the UK? And then to further that from Adam, are there any known V2 craters near Enfield?
Lots near Enfield, because London was the main target. Sean?
Right, there was roughly 1,100 fired against England. The ones in London will have been filled in and they will have probably been built over. The ones in Kent, you can still find existing craters like this, but Kent was never the intended target. London was always the target. We know where every single one of them are, and we've plotted all of that on a map, and we can actually run a time sequence showing the rockets coming down as they came down.
And the V1s too.
And we could do that with V1s. There was coming on for 10,000 V1s. So, yeah.
Next question.
Just seeing what else is happening. So I have a question, because you're in, you mentioned being in a wood there.
Yes.
Just kind of managing, you know, protected vegetation, and what's the expectation around clearing and, you know, kind of managing
That's interesting.
digging versus,
Yeah.
you know,
Let me
are
take
there
you to.
particular species that are more protected, that kind of thing?
Yes, very interesting. Dan. Let me just introduce you to Dan. Here we go. This is Dan Chewson, who's here because he's interested in the project, but he happens to be a Natural England representative, works for Natural England, who look after our natural sites.
Yeah.
So this particular site is called a triple SI interest, and it's mainly for one reason, isn't it?
Yeah, I mean, it's known for probably the country's biggest breeding population of nightingale, which is becoming a fairly scarce bird, a summer migrant here in the UK, and the numbers have gradually declined over the last few decades. But this site, with its woodland and really scrubby undergrowth, is a great nesting site for it. So it's a very important site from that point of view.
And actually, our activities, if I clearing the coppice and having an open area here, what's going to happen very, very quickly is the brambles will encroach. We've actually created a nice breeding ground for the nightingales. Probably not next season, but the season after, we shall certainly have enough undergrowth. So part of our work is actually helping conservation of an important species.
Yeah, indeed. Yeah.
Fantastic.
Does that answer your question?
Yeah, no, that's perfect. Thank you.
Right. Does anybody have the time? I've got to be conscious of.
It's about past now, so.
Okay. Are there any other really important questions? Because I've got this, I don't know what it is. I've got this sort of boyish feel about things right now. I want to know what's in there. And it's tempered with an adult feeling of, oh, good God, I've got all these people here. And what happens if we've got it wrong? You know, it could be something completely different that is at this spot where we've got the strong reading. Anyway, the answer
ask a historian's question. So firstly, thank you for offering us this wonderful opportunity. Could you tell us a little bit about how much you think was salvaged after the impact, and also both through official salvage teams, but also through possible souveniring as well? I know there were huge shrapnel collections amongst children during wartime in Britain. Can you tell us a little bit more about how much material you think was removed post-impact?
Well, part of the reason we do this, the V weapons, is in relation to the V2 rocket. Some of the documents that describe what happened, there are teams that came out to record the crater depth size, how it was known that it was a V2 rocket. Some of those teams put a little message on those forms, on those census forms, that said, let's get my hand out of the way, that said, presumably blasted to smithereens, presumably vaporized. Well, we didn't think that was quite right as we started to go through the sites, doing the preliminary surveys, because we were finding bits of them. But the real thing that broke that myth for us was the Linstead V2 rocket that we excavated that I mentioned earlier, that went down. The crater was 18 feet deep at the time. We excavated to 18 feet and found virtually nothing. So we backfilled this great 60-foot by 18 feet crater, and then went home and thought there's something wrong here. That's when we went down to 28 feet, the next excavation, and we found it all. And the reason we weren't seeing any evidence is because the strength of the impact, basically, it's like it melts the chalk. It returns it to its liquid form that chalk actually exists in at great depth. So it was going into the chalk, the doors were closing behind it, and that was it. Souvenir hunting, yes, the blast field wreckage that we found around, that's what people would take at the time. There was somebody who managed to find a magnet on one of the authorities that we spoke to. The teams at the time, the reason they were recording so thoroughly is because they wanted as much evidence about the missile as they could possibly get. And there was one that actually crashed virtually whole in England. That was useful, but that wasn't enough. They needed to keep checking what they were finding to make sure that things weren't being further improved to cause us more threat. Is that enough of an answer?
Great, thank you very much. Appreciate it.
Daniel?
Yeah.
Are you there, Dan?
Yeah, very good. Thank you very much, Colin.
Okay. Well, Daniel, I want to thank you for putting this together, because that is not an easy job, what you've just done for us. I hope that everybody's enjoyed it, and tomorrow you tune in to see part 2 to see what actually came out of the hole.
Yeah, looking forward to it, and I'm getting a whole heap of nods from everyone else. So good luck with it, and we'll see you tomorrow.
Okay. Thanks very much.
Thank you.
Bye.
Thank you.
Bye.